Hello, my name is Lindsay Dante. I work as a systems engineer and I'm also a member of the WISE Young Professional Board. Today I will be discussing the physics behind running and how to run a great 100-meter sprint. So many of us witnessed St. Bolt win gold at the Beijing 2008 Olympics, where he ran a time of 9.69 seconds, setting the world record. Later on, the following year, he also broke that record, running a time of 9.58 seconds. So you must wonder, how does he run so fast? How do athletes do it? It can be said that the fastest people on earth have enhanced running skills as well as motor coordination, which allows them to reduce the negative forces that act on their body during sprinting. There are three main forces at play when you are running. These are gravity, inertia, and friction. Gravity is the force that pulls you down. It keeps us grounded on Earth. Now let's not forget Newton's third law of motion. For every action, there's an equal and opposite reaction. So this is saying the force that's pushing you into the ground in this moment will subsequently bounce back and propel you forward. This force that propels you forward is called inertia. Once you start running, you will make contact with the third force, friction. Every time your foot makes contact with the ground, there will be conflict between your inertia of velocity and the friction of the ground. Friction will try its best to stop you. Newton's first law of motion states that an object either remains at rest or continues to travel at a constant velocity unless acted upon by a force. So in this case, if you are moving at a constant velocity, and we must remember you will have inertia, friction, and gravity acting upon you, you will begin to slow down. So you must be asking yourself now, how do athletes use this understanding of physics as well as forces to their advantage so that they can break records and run really fast? So in order to overcome these negative forces, most athletes keep their bodies upright to make sure that gravity and inertia don't take them down, as well as make sure that their feet spend as little time as possible with the ground so that they can reduce the amount of friction they experience while sprinting. So now, going back to Usain Bolt, he was able to maintain both top velocity and top acceleration while sprinting. This is because at 6'5", Usain Bolt has really long legs, and these long legs gives him long strides. So you can imagine that every time he takes a step, he covers an enormous amount of ground in comparison to other athletes. Every time he also takes a step, he also exerts a huge amount of force on the ground. As we explained with Newton's third law of motion earlier, the ground in this case will apply a huge amount of force back when Usain exerts the force, and this propels him much faster going forward. The amount of force you can give to the ground depends partially on your technique, but mostly on how much strength you have in your muscles. Bigger muscle generate bigger force. This is why most athletes spend time working hard on the track as well as in the gym lifting weights to build muscle. However, strength is not just how big your muscles are, but how much force your muscles are producing whilst they are moving or in motion. Athletes tend to work with sports scientists as well as strength coaches to understand how their muscles function whilst in motion. This helps maximize their performances. So now, I hope you've come to the realization that physics plays a big role when it comes to running, especially when it comes to maximizing the performance of professional athletes.